Hopefully everyone is here, but I did say that I was nuts. I did say I was going to start recording the Zoom sessions. All right. Hopefully everyone sees my document camera, my screen. And what do we know about secondary alcohols and HCl? Secondary alcohols and HCl proceed via SN1 carbocation. So your product will be scrambled if you have a chiral carbon, and we have Cl plus Cl. That is a mixture of enantiomers. One's R and one is S. If one of these is a drug molecule and the other one is toxic, actually Aleve. Aleve is the chemical name for Aleve, the pain reliever, is naproxen. And they did find out, I don't know if they found out right away or there were some lawsuits, but they did find out that left-handed naproxen was the pain reliever, but right-handed naproxen actually was really toxic and it really destroyed people's livers. So when you buy Aleve from the drugstore, okay, it's going to come in as one enantiomer. It cannot be a mixture. Okay, they would get in huge trouble if their chemistry is not good and they were making mixtures. Okay. How about this one? It's the same deal. It's secondary and it's HCl, so it's going to be SN1. But look what we get in terms of the product mixture. So I'm going to make this chlorine wedge. This carbon all the way on the left, nothing happens to that. Nothing happens to that. So it stays wedged. But the chlorine could come in from the back also. So that's dash. Again, nothing happens to this carbon on the left. All the action takes place right here on this carbon that's connected to the oxygen. Now you might wonder, oh, Dr. Gabriel said this was achiral. It has a plane of symmetry. So why am I doing wedges and dashes? You could have wedges and dashes on an achiral molecule because can you imagine what's going to happen if I made this dash? This is a ring. We have cis and trans relationships. These two are trans to each other. That's definitely a different molecule if these were cis. So cis and trans are different molecules. It just happens to be that this has a plane of symmetry. Okay. So we have to draw wedges and dashes, or it's proper to draw wedges and dashes because there's a difference. If I had this a line and you didn't know whether it's wedge or dash, you don't know whether you have a cis or trans cyclohexanol. Okay. So hopefully you understand why I'm allowed to put wedges and dashes, even though this carbon is not chiral. Mixture. Mixture of what? These are not enantiomers. You can't have an enantiomer of an achiral molecule, right? Because there's a plane of symmetry. But what do we have? We have a cis version and we have a trans version. Those aren't enantiomers. Those are diastereomers. Diastereomers are stereoisomers that are not mirror images. Diastereomers. Okay? So far we have different results, right? For the first reaction, we get one product, pure. For the second reaction, we get a mixture of enantiomers, hard to separate. For the third one, we have a mixture of diastereomers, easier to separate. What is this? This is dehydration. Right? Dehydration, you're making alkenes, and you're doing beta hydrogen elimination. Okay. Let me make the double bond to the left first. But you know that this bond rotates. So when you eliminate the OH and the beta hydrogen, that methyl group can be exactly where it is, or that methyl group can be down here. and that's a possibility. We get cis and trans alkenes when we do dehydration. If you have a molecule that can show cis-trans. Because look at what happens when we do the double bond on the right for the beta hydrogen on the right. We don't have cis-trans isomerism because this carbon has 2 hydrogens on it, 2 of the same groups. So, I mean, how can you draw? You know, if you think this is trans, I dare you to draw the cis version. There is no cis version because this is not even trans. This is just neither cis nor trans. Well, what do we have here? You know, these two have different connectivities. So these two are constitutional isomers. We went through cis and trans. So even whether you have a ring that's cis and trans or a linear alkene that's cis and trans, those are still what? They have the same connectivity, so they can't be constitutional isomers. They're not mirror images, so they're not enantiomers. These two are diastereomers. So here you have a mixture of constitutional isomers and diastereomers. Okay. All right. There are many, many ways to assess whether you understand the videos and whether you understand the textbook. I'm trying to provide as many different ways to ask a question or ask a problem in the practice problems. Essentially, I'm going to try to stick to those types of problems. Okay, so if you can be a master at these practice problems, you should be in good shape. B, high Bs. Now, if you're able to get my problems that are a little bit worded differently or a little bit unique, then that's when you could get the A's. And you know, talking organic chemistry with either Jose or me or your classmates, you know, often, so this terminology starts to be very, very automatic. That's going to help you tackle any problems where the wording's a little bit odd or the approach is a little bit different. Okay, so let's go back to the problem set. Okay. Again, I'm trying to give you a variety of different problems. Yes, essentially most of them are going to be fill in the products and the mechanism. Okay, but we've already seen a synthesis. We've already seen a product mixture analysis. Over here, we're not going to do this together, but here is fill in the reagent. Okay, what is the strategy here? The strategy here is, for instance, for the first one, the strategy here is what is different between the starting material and the product. Well, the triple bond stays the same. The double bond stays the same. We oxidize. We oxidize the alcohol into a ketone. So what kind of oxidations do we know? Well, if you go back to Moodle, what is this? Uh-oh. Oh, no, that's not what I want to do. Shoot. Give me 1 second. Let me find my... Oh, here it is. Yeah. So if we go back to Moodle, and... Sorry about this. We go back to... My goodness. Go back to the list. What was I doing? I was trying to figure out where can we see that oxidation, right? Well, it's this one right here, Jones oxidation of alcohols, going from an alcohol to a ketone. Okay, this was a pretty good video because I was able to fit in also reduction, the opposite. So these are complementary, oxidation and reduction. Okay, let me remind you what our task was. Our task was to figure out what methods can we use to do this oxidation. there are two reagents, two distinct reagents, right? One was chromic acid, secondary alcohol to a ketone. The other one was PCC. So you can use PCC to get the ketone as well. Okay. So stuff like that, you want to be good at predicting the reagents. Okay. Okay. So like I said, there were 8 problems. The plan was to give you an extra credit assignment, and let me show you on Moodle what that assignment will be. Again, because it's a 4-week class, this one keeps jumping. Because it's a 4-week, nope, that ain't it. Sorry about that. Because this is a 4-week class, the better you are organized and the better you keep track of due dates, okay, the easier things will be. So let me show you Moodle. Let's stop this. Okay. I'm trying to set off all the submission links with this word submit. Um, most of you have done this already. What are some other ways to improve your grade? Okay. Friday, we did discuss this. You had around 48 hours to get the Unit 2 video notes submitted. I promise to get you your Unit 2 problems soon. Okay. So just watch the videos and take notes. Tomorrow, I am providing an extra credit, and you're going to submit your extra credit to this link. And what is that extra credit? That extra credit is to complete the roadmaps from today. Okay, so for the last, I don't know, 15, 20, 30 minutes, I'm going to give you that roadmap to complete, and you're going to submit it by 24 hours, right? Tomorrow by 11:30 a.m. Okay, so let me do that for you. Okay. I'm going to use a new page, and we're going to call this extra credit roadmap due Thursday, 11:30 a.m. Extra credit. Roadmaps. I'm going to try to do several. This was for +3 percentage points. And again, it's due Thursday, tomorrow, 11:30 a.m. It's going to be mostly based on what you've seen already, the alcohol, ether, and epoxide chapter. All right, so you do have to copy this. Hopefully you can see my screen well. It's the alcohol chapter, basically. So why don't we have an alcohol that looks like, I had this drawn out. Oh yeah, that looks like this. I'm not going to put dashes and wedges because that carbon is not chiral. Okay. Someone's talking on chat. Jose, just speak up. Okay. Can you can't see the document camera, Jose? You still can't see it. Okay. All right. Sorry about that. How about now? No? You can you can Okay. Got it. Oh, that was strange. All right. You're copying this, and you're going to fill in the arrows. Now, if there's more than one way to do the transformation, then you only have to put one way. You don't have to put all the ways. We've been working with chlorines. Why don't we work with a bromine? So how do we convert this alcohol to a bromine? It may be helpful, and I don't care if you mark up your assignment, but I think it'd be useful to put some notes, right? Because you're going to use this eventually as a cheat sheet or a study sheet. You know that your exams are open notes, so maybe if you could get this really looking good, you'll have all the reactions at your disposal. Okay. All right. What about this reaction here? Oxidation. I like that. Uh-oh. Is there anything else? Oh, how about this one over here? Well, what can I do? I can do this, or I can make the cis version. Okay. Again, you're copying this, and then you're filling in the arrows. Let me put that there. Fill in reagents. Okay. Huh. What can I do? I could always go back to YouTube and say, well, what reactions am I missing? I could always go back to the notes, right? Because we had A, B, C, D, all the way up to, I think, M. Substitution, oxidation, elimination or dehydration. Don't tell me, guys. I'm trying to think of some new reactions. Well, how about this? So this may require more than one reaction, but you're allowed to use 1 and 2. So you're allowed to number your reactions if you need to do a sequence of multiple reactions. I want this one. Give me a second. This nucleophile CN. And I think that's all I'm going to do for that roadmap. Secondary alcohol. Well, what happens if I do... I could have a little more variety, actually, if I just use a primary alcohol. Okay. I don't know how soon I could get these notes posted. I don't know how soon I could get the video processed as well. So if you want to do this today, then I would definitely make sure you copy this or take a screenshot or take a photo from your phone, okay? Because that is what is due tomorrow, but there's more, okay? So this one, I want us to make the aldehyde. But there's a reagent that you could oxidize it even further to the carboxylic acid. Okay. Man, I am at a loss for new reactions. Let me go to Moodle. Let's see. Why am I going back to Moodle? Because I actually want to see my list. Okay, hopefully you can see my YouTube channel. Oh, I could do that. Don't tell me. Oh, we have ether stuff. Williamson ether. And we have epoxidations. Got it. Okay. All right. You can see my document camera back, hopefully. And I'm going to add to this. What if I do this? Give me a second. Let me figure this out. Okay. What if I make this? Oh, let's just use that. That's an ether. Okay. Again, some of these arrows may require a sequence of more than one reaction. But here's an ether from an alcohol. And then I'm going to challenge you. What if I want to make, again, this is going to be a sequence of reactions. What if I want to make this the epoxide? from an alcohol, though. And you think of a sequence of reactions where I can ultimately get to this epoxide with 3 carbons. Okay, this has 3 carbons as well. So I'm happy with that. And then we're going to take this epoxide. Okay, I know it's getting out of control, but what if I make this? Give me 1 second to figure this out. Okay, that's a challenge. And I could open up the epoxide in the opposite way and get the OH on this side and the chlorine on this side. If you remember from your epoxide video, that this is based on whether you're attacking under acidic conditions or non-acidic conditions. Whether you're attacking the more substituted carbon or the less substituted carbon. How's that for extra credit? So we're going to zoom out. Okay, sorry about that. I'm going to try to scan these. It just depends. I'm on campus, so it just depends whether the scanner is working or not. I'll try to scan this right after class. But that is your extra credit, okay? So how many arrows? Count on your notes how many arrows you have to fill in, and I'll count on mine, and let's see if we match. Oh, nice. 10. Okay, 10 total arrows. You gotta fill this in, take a picture. Again, I don't care. This is your cheat sheet. This is extra credit, but I'm looking for what's over the arrows. But as if you're going to use this as a cheat sheet, why don't you name these reactions also, right? This is oxidation. This is substitution. This is elimination. This is ring opening of an epoxide under, I'm not going to tell you, one of them is under acidic conditions, one of them is under non-acidic conditions. Okay. Are there any questions about that? Okay. I can't do this every single unit, okay? But I am showing you what is the strategy, right? The strategy is to go through your videos and notes and then fill in the products, because I think this is harder, correct? It's harder to fill in the reagent than it is to fill in the product. So hopefully you'll study a little bit, you have your notes, and you'll do these more challenging problems where you have to fill in the reagent. Some of them are full-blown synthesis that's going to require maybe 2 reactions or even 3 reactions. All right. Okay. What else do I want to talk about? Oh, announcements. Okay. We are going to end a little bit early. All right. Again, I'm going to try to get these posted so you have a PDF copy of these notes. Right. You know, I too have to stay pretty organized because I got to remember what to grade. I'm going to try to remember what I promised you in terms of extra credit. Before we go back to Moodle, just to make sure that I'm not missing anything, office hours. So again, Jose Sessions. Okay. Okay. Hopefully you can see my document camera. Jose Sessions, you attend once a week. Okay. But I think a lot of you are attending multiple Jose sessions because I think they're pretty useful. But if you attend once a week, you get 5 out of 5 points for the week. If you look at the syllabus, those of you who are new and did not have me for Organic Chemistry 1, there are 4 weeks. You could easily get 20 points, right? 5 times 4, 20 out of 20 points. Okay, that total is 10% of your grade. All right, Jose texted me his availability. You're free to ask about any problems from the after video assessments, or if he's willing, you could ask questions about the roadmap that's due tomorrow. So today, 4 p.m., 4:30, I mean, Thursday. Oh yeah, we have no Zoom class, so he's going from 9 to 11 a.m. and 1 p.m. Friday, we do have class to 11:30, and then Jose has office hours at 1 p.m. And then Sunday, the night before the exam, he says around 7 p.m. Okay, maybe an hour. For me, um, for GG, today none. Give me a chance to make those problems, post the PDF, post a video link. So we'll say none for here. Thursday. Um, so Jose is 9 to 11. I could do 11 to 1. You should visit me, okay? I tend to slip up and I tend to give a lot of, not a lot, but I tend to give some hints about what might be on the exam. Friday, we have a Zoom session. I'm gonna say none. Saturday, I'll be available Saturday, to be announced, to be determined, and Sunday, to be determined. But most likely, Jose would be the last person. I'm not gonna have office hours Sunday night, maybe Sunday during the day. Okay. All right, so those are the office hours. Let me just double check. Well, let me do this from memory. What is due in lecture? Okay. Your extra credit. Again, if you're swamped, okay, and you don't want to do this roadmap, okay, that's perfectly fine. Um, but the extra credit was, I think, for plus 3% on exam one. That is due Thursday at 11:30. I don't think I'm going to extend the deadline though. Okay, I do have extended deadlines for your video notes. All right. I see there's a question I'll get to in just a bit. Um, okay. What am I doing? Due Thursday, 11:30. The Unit 2 videos, and I posted all of them already. There are 5 of them. That is due Friday. I think I said 8 a.m. I'm pretty sure I said 8 a.m. because I want everyone to be on the same page. So if I could get everyone to watch the Unit 2 videos and take notes before our lecture at, what is it, 10 a.m., that would be great. And then I could start reviewing Unit 2. Okay. Unit 2 is interesting because what are we doing in Unit 2? We're taking these molecules, the carbonyls, like an aldehyde and a ketone, that we can make from alcohols, and we're making a bunch of roads from those two types of molecules, aldehydes and ketones. Okay, so it is very fitting that we're doing aldehydes and ketones right after we did alcohols. Okay. Um, for lab, those of you who are taking lab, I think there's something due. It's your notebook and your post lab problems. That is due. Don't tell me. Don't tell me. Usually 48 hours. So I posted this on Tuesday, so tomorrow actually, Thursday. Okay. Can someone yell out, when is your notebook and post lab due? It's Thursday afternoon? Yeah, it has to be afternoon. Does anyone know? No one knows. Is anyone taking the lab? Let's see. Am I alone in the room? Oh, that does remind me one more announcement. So the lab is due Thursday at 5 p.m. Okay. Let me show you what I have on the document camera. Oh, we have some questions. A good problem with a process is how to make it turn. Okay. Um, Everything circled, that is the easiest way to improve your grade by getting these assignments in on time. Okay. Which brings me to the last point. Let me just check my participants again. All right. I'm going to make you guys eventually use your raising your hand or speaking up and interrupting me. But the last announcement is, I think today is a drop day. Okay. So it's called add drop. 5 p.m. today. Okay, I mentioned this because uh, I know Organic Chemistry 2 has only been 3 days, Monday, Tuesday, and today. Hopefully you see how much time commitment, or you could gauge or predict how much time commitment there is. This is just the first 3 days, okay? And I don't think it's going to slow down um, because we do have to get, 3 units per week, okay? Um, if you feel like you're behind already, okay, or if you feel like your Organic Chemistry 1 training is not really solidified, I can only imagine that this is going to get harder for you. Okay, if you're not coming to my office hours, or if you're not going to Jose's sessions, and you don't have time, or you're not scheduling in that time to meet us, then I can only imagine that this is going to get harder. Now, I do understand that some people, I mean, I think I've had classmates, and I've done this in other classes myself, that I'm going to eat it. I'm going to eat the D or the F, but at least I'm getting the information. That's one strategy. It just depends on, how Oglethorpe calculates GPAs, what's going to be on your transcript. Every school is different. But I totally understand that if you want to stay in class, even if you're struggling, that's fine. There's all types of people and all types of strategies. Um, but today's add drop, meaning that I think what that means is that if you drop, you get a full refund on the tuition. Okay. The thing is, you have the textbook and you have the YouTube link. So if your goal really is just to get super prepared for Organic 2 in the spring, you have all that available even if you're not registered for the class. Okay. The only thing that wouldn't be available is I wouldn't be able to give you an exam and I wouldn't be able to grade your stuff. Okay, but if it's just for the information, you could do that without being registered. Um, I do hope all of you made it through Organic 1, so you do have what do you call it? The skills, but you also have the motivation, the determination to get through Organic 2. I'm just trying to warn you that it is going to be um, pretty packed and um, a lot of due dates. So just try to stay organized. I think that's all I want to say for today. By Friday, everyone should be caught up with Unit 2. Um, I promise you to get the practice problems. So we'll do a little review of Unit 2 on Friday. Um, I hope to get Unit 3 actually posted by Friday as well. Hopefully by tomorrow. That way, by Friday, you'll have all the information, and you could just spend Saturday and Sunday reviewing that information and doing practice problems. Okay. Are there any questions? I know that I haven't updated. So on Moodle, there's a grade uh, menu. I haven't put in anything. So if it's all blank, it should be all blank because I haven't added anything yet. But don't worry, Jose is keeping close track of the extra credit, and I'm keeping close track of the extra credit and also your assignments that you handed in. All right. If you have any, I said none. If you have any questions, either concerning about the material or just the class logistics, um, I can't meet today, but just email me. I'll be checking my email constantly. All right. So I don't think there are any questions. Um, you're allowed to leave the room now, except for Jose. And I will see everyone on Friday. Okay. But stay in contact. Email me if you have any questions. All right, Jose, stick around. Man. What what did you say? No. No. Let me find. I gotta stop this video. Um, man, how do I do this? Oh, click here.